Good morning, students. Today we are going to discuss the next method to solve the algebraic and transcendental equation, that is secant method. Let us look what is the meaning of secant method. Okay, as we have already discussed this flowchart. Once again, I want your attention just to find the root of any nonlinear single variable equation. There are two known methods. One is open method, another is your bracketing method. This is open method and this is bracketing method. Under the open method, we have already discussed method of iteration, Newton-Raphson method. Under bracketing method, we have already discussed bisection method and fast position method. So today we are going to discuss secant method. So this method we are going to discuss in today lecture. What is the basic of the secant method? In numerical analysis, the secant method is a root finding algorithm that uses a succession of the root. Just to check it, a succession of the root of secant lines to better approximate a root of a function f. The secant method can be thought of as a finite difference approximation of Newton method. Okay, if you discuss about the methodology, so this is the methodology how to derive the formula for secant method. Okay, so here you can choose a secant line is defined by using 2 points on a graph of function f(x). It is the 2 points are xi, this is the xi, and the next point is xi minus 1. So you can choose these 2 points. The next point is, of course, is xi plus 1. Okay, so now we can obtain a secant line passing through these 2 points. These 2 points means this point. So this point is xi and f of xi, and this point is the xi minus 1 and f of xi minus 1. So you know the equation of the curve joining these 2 points. By using that, you can develop the formula. So this is one way to develop the formula for secant method. Another method is also very easy. You can check here and very easily this the graph, the same graph. The secant method can also be derived from the geometry, very basic geometry of the school level. AB by AE. Okay, here in this graph, AB, this point, so AB by AE. So AE is this. So AB by AE is equal to DC. You check. This is DC by DE. So DC by DE. So can be written as this. And now from here, you can develop this formula very easily. That is xi plus 1 is equal to xi minus f of xi minus xi minus 1 divided by f of xi minus f of xi minus 1. You know how to calculate the absolute relative approximation error. So absolute relative approximation error is a decision making in secant method. With this decision, you will decide you will just continue only and get the solution in step 1 by using this formula in step 1 only, and you need to go in step 2. If required, then we can go for step 2. Step 2 means we may proceed this step if the absolute relative approximation error is greater than the prescribed relative error tolerance. If so, go back to step 1. Otherwise, stop the algorithm. Also check if the number of iteration has exceeded the maximum number of iteration. Okay. So in this way, now let us look the problem. So this is the problem I have chosen just to discuss here. Cosine x minus x e power x is equal to 0. So now first of all, you have to check where is the root, where the root is lying. Okay, here f0 is 1, f of 1 is negative. So root is lying between 0 and 1 here. It means xn plus 1, you know this formula, xn plus 1 is equal to xn minus xn minus 1 minus xn divided by f of xn minus f of xn, f of xn. Okay, so after putting the values, here you check x naught is equal to 0, then x1 is 1, and f of x naught. So you put here, you will get here f of x naught is 1. And what is f of x1? The f of x1 is minus 2.1780. After taking these values, we have obtained the next approximation to the root as x2 is equal to 0.3147 and f of x2 you will get 0.5498. Okay. Therefore, x3 you can calculate by repeating the similar procedure, and x3 you will get 0.4467. Please check it. Okay. Then after getting x3, you have to again find out with the similar procedure f of x3, that will be 0.2036. And then moving further, you have to find out x4. x4 you will get 0.05318 and f of x4 is minus 0.0432 this. Then x5 is 0.5168 and f of x5 is minus 0.0029. Then in this way, repeating the further, you will get x6 that is 0.5177 and f of x6 is minus 0.000, mind it, 0002. This is very closer to 0. Okay, so this value is going to closer to 0. Okay, just to check here, key 3 places 0. So x7 is 0.5177. Check here, 0.5177, 0.5177. Okay, so add up to 4 decimal places. The convergence is here, and you can stop your calculation by declaring this is as a root 0.5177 up to 4 decimal places. So here you can apply the secant method. Secant method is one of the analytical procedure available to earthquake engineers for predicting earthquake. So this is a very important application just to identify, predict the earthquake. We always use the secant method. The secant method is used to develop linear dynamical analysis model to have the potential to influence the behavior of the structure in non-linear range. It is also used for non-linear push over analysis, which defines the force displacement relationship of the walls in the building lateral load. Okay, so here also we use the secant method. And what is the advantages of this method? It is converges faster than a linear rate, so it is more rapidly convergent. This method requires two guesses that do not need to bracket the root. Okay, it does not require use of derivative of a given function. जैसे हमने न्यूटन रेफसन में देखा, यहाँ नहीं चाहिए हमें, because in some cases derivative becomes very hard to find. You know, there are many functions where the derivative is tough also. So it requires only one function evaluation per iteration as compared to Newton-Raphson method, which requires two functions. No need to check for sign here. Okay, so now what is the drawback? Drawback is because the secant method is not a bracketing method. ये ब्रैकेटिंग मेथड तो है नहीं, सो इट मे नॉट कन्वर्ज. ओके, इसलिए आपने देखा होगा कि कन्वर्जेंस थोड़ा मुश्किल होता है और कभी कभी कुछ प्रॉब्लम में कन्वर्ज करना जरूरी नहीं है. दिस मेथड डज नॉट नो व्हेन टू स्टॉप. इफ द फंक्शन इज वेरी फ्लैट, द सेकंड मेथड कैन fail. Okay, so this is the drawback. And what is about the convergence? As we have already discussed in the previous PPT also, there is was the meaning of convergence, but once again I am repeating here, because the secant method is not a bisector, this bracketing method, so it may or may not converge. हो भी सकता है और नहीं भी हो सकता, लेकिन चूंकि ये bracketing है नहीं, तो convergence जरूरी नहीं है. This is one of the important viva question always asked during your numerical experiment or C++ programming laboratory if this is applicable in your case. But when the method converges, it can be shown to have an order of convergence which is equal to 1.618. So this is about the secant method. Thank you very much. Thank you.